The best performance improvement I remember I ever did, I made something about 1,000 times faster by removing a time.sleep that I'd left in there by mistake. They were thrilled. They were like, this is really fast now. I look like a hero. Instead, I was, of course, an idiot in the beginning. So do you recommend that? Put some time sleeps in early and then you can take them out over time?
Maybe it's a genius move, right? You just put them in and then remove. Ta-da.
Ta-da.
It's an improvement.
Yeah.
This episode is brought to you by SourceGraph. SourceGraph is universal code search to let you move fast, even in big code bases. Here's CTO and co-founder Byung Lu explaining how SourceGraph helps you to get into that ideal state of flow in coding.
The ideal state of software development is really being in that state of flow. It's that state where all the relevant context and information that you need to build whatever feature or bug that you're focused on building or fixing at the moment, that's all readily available. Now the question is, how do you get into that state where you don't know anything about the code necessarily that you're going to modify? That's where SourceGraph comes in. And so what you do with SourceGraph is you jump into SourceGraph. It provides a single portal into that universe of code. You search for the string literal, the pattern, whatever it is you're looking for. You dive right into the specific part of code that you want to understand. And then you have all these code navigation capabilities, jump to definition, find references that work across repository boundaries, that work without having to clone the code to your local machine and set up and mess around with editor config and all that. Everything is just designed to be seamless and to aid in that task of code spelunking or source diving. And once you've acquired that understanding, then you can hop back in your editor, dive right back into that flow state of, hey, all the information I need is readily accessible. Let me just focus on writing the code that implements the feature or fixes the bug that I'm working on.
All right, learn more at sourcegraph.com and also check out their bi-monthly virtual series called DevTool Time, covering all things DevTools at sourcegraph.com/DevToolTime.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. This is our final episode of 2022, but have no fear, we'll return in the first week of January with a New Year's episode that you don't want to miss. Quick shout out to our partners at Fastly for shipping Go Time to you super fast all around the world. Check them out at fastly.com. And to our friends at fly.io. Deploy your app servers close to your users. No ops required. Learn how at fly.io. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer and today we're talking about making Go more efficient and how best do we do that. I'm joined by Bartłomiej Płotka, author of Efficient Go, which was released last month, principal engineer at Red Hat, and a Prometheus and Thanos maintainer. Hey Bartek, welcome back.
Hello everyone. How are you?
Very good, thank you very much. And you're calling in from London, right?
That's correct, yeah.
Yeah, cool. I'm also joined by Kemal Akkoyun.
Hello, Matt.
Hello, you're a software engineer at Polar Signals, right? Also a Prometheus and Thanos maintainer, and you're currently building an open source eBPF-based continuous profiling solution called Parker. Welcome.
Hello.
Great to see you. This is your first time on Go Time, I think, isn't it?
Yeah, it is.
Yeah, good.
A bit nervous.
Yeah, oh, don't be. I am a bit as well, just because of the sheer brain power on this episode. I'm out of my depth. I'm also joined by Christian Simon. Christian is a software engineer at Grafana Labs, working on observability databases like Loki, Mimir, and the new one, Flare. Hello, Christian.
Yeah, hi there, Matt. How are you?
I'm good, thanks. Welcome to Go Time. It's nice to have you here. Let's get to know our guests a little bit, shall we? Kemal, what's your favorite drink?
I guess I have two. One is single malt scotch and the other one is coffee.
Oh, nice. Yeah. Do you have them together? Like there's Irish coffee that we call it. We mix them together.
No, I have them separately, one in the morning and one in the afternoon.
Okay, we won't ask which is which. What about you, Bartek? That sounds pretty good, doesn't it?
Yeah, definitely. It's a +1 from my side as well, like coffee and whiskey. And I got approval from my personal trainer as well. He said, whiskey. Is it clean at least? And I was like, yeah, clean, just ice. And she was like, okay, that's fine. So I think it's good.
Oh, wow. Yeah. That sounds like a good personal trainer. Christian, do you have a favorite tipple?
Yeah, I think when I'm at home, I'm definitely more on the juice Schorle, with spritz. Basically, so I'm originally from Germany, so that's a drink there.
I see.
But yeah, I think given the feedback from the personal trainer from Bartek, I think I might need to change that and revisit.
Yeah, no wonder you're not ripped. You're not drinking enough whiskey. Oh, you're from Germany, so okay, that's why we're doing an episode on making Go more efficient. Makes sense. That's the classic stereotype, everybody, which I don't recommend.
I guess people haven't lived in Germany.
I don't know. Well, you have, haven't you, Kemal? Because you live there now. Do you like it?
I really like it. I like it, Berlin. It's been 5 years.
Wow.
Learning to be a German.
Yeah.
Slowly.
Nice. I think Berlin's a great city as well. GopherCon EU was there this year, so I got to go and hang out in Berlin, and we had a great time. That's the small talk over. The small talk section is now finished, okay? So you can, no more small talk now. Let's get down to business. I want to know just something initially, like making code obviously more efficient. I think it's kind of the case for it's obvious. You don't use as many resources. It's actually sometimes like the greener thing to do as well, because you're using literally less energy, especially when you get at scale. But for sort of like people that are new to writing Go or they're just getting started, do they have to worry about the efficiency stuff from the very beginning? Is this something that you should just get it working first and then you can make it more efficient later?
So, there are two schools actually, right? One is that the saying that premature optimization is the root of all evil. It's like very old saying that got very, very, very popular, especially in 80s and 90s then. And that was kind of claiming that engineers are playing too much. They are having too much fun of making, those optimizations and efficiency improvements that at the end didn't matter and actually make things worse because the code was unreadable, unmaintainable, and changing it to be faster for different circumstances was harder. So at the end, it was less efficient, right? So that's one school. And I think there are good kind of like good truth to be learned from that. But nowadays, I'm kind of like, maybe discussing in my book as well, but also in my talks, that sometimes we are too afraid of touching the efficiency topic. So we are always kind of putting that as a last step in your development practices, last priority. And you are kind of like, those are excuses to not do this, maybe a little bit extra additional work to make things faster and more cheaper to run. So we can go deeper, but generally, yes and no. Generally, especially if you are learning, focus on readability, maintainability, and those kind of first things that you have to learn how to make your code functionally running. So kind of like fulfilling your functional requirements. And then you can optimize it later. However, with time and if your team is more kind of productive and can learn more, can use tools that we hopefully will talk about around how to make things more efficient, you can kind of like move this step sooner in your development process. However, you have to know what you are doing. So if you're new to Go, definitely don't even aim to make code more efficient until you have to do it, and then you can learn how to do it. So that's the balance I'm aiming for.
I would definitely agree. I guess with many other things, I think a balance of the two is probably good. And kind of the better you understand your ability, your team's abilities, but also maybe the problem space. Like, let's say you attempt a rewrite of something you think you understand quite good. I guess then maybe efficiency is some of the reason of that rewrite. While maybe you're trying something completely new and you might just have the wrong assumptions what you're optimizing against. So there's no one size fits it all, I guess.
Yeah, I totally agree for both of the statements. But I guess as Bartek put that, I belong to the first school, and the original quotes from Donald Knuth, and it says 97% of the time. So I think that 3% sometimes makes the difference. And you can always determine that 3% by measuring things, right? And in Go, we have lots of tools around that you can actually measure and benchmark and decide, maybe even from the beginning, what to optimize.
Yeah, so this is interesting then. And I kind of like what we're going to get into, this idea that we don't really know what we can do to make it more efficient necessarily. And sometimes even experienced engineers will have a really good idea. It'll be really obvious, but it turns out that it doesn't necessarily make any impact when you make certain changes. So how do we know when we've got the opportunity, when we've found that 3% to make something more efficient? How do we know?
Well, we need to make some measurements. We need to observe our system under load, under kind of requirements we set it to be running with, and essentially observe what is causing the problem, and then generally at what level of kind of efficiency we are in. So those kind of like two things that generally I'm in my book kind of mentioning, that you need to assess your efficiency. You need to be able to assess your efficiency, because perhaps you are actually fast enough. It's actually some other component that is causing the problem, or something might be outside of requirements. Maybe a request is going to your HTTP server written in Go and it's actually, malformed request. That's why things are slow. So maybe some safeguard check is enough. So this assessment is one thing, and you have to kind of measure that. And that might be, and that's generally in kind of observability space we are going into. You have to measure it while running, either running on production or locally under your benchmark, we call it. So test and experiment, right? So assessment is one point. And the second point is bottleneck analysis. So once you know that things are too slow, so you generally know you are, for example, like 1 second behind your expectations of the HTTP request, for example, you can go and find some tooling around observability that will tell you the bottleneck. So what part of my code is actually a main contributor for the problem, right? Maybe it's too slow. Maybe it's using too much memory. And that's a bottleneck, right? And that can be multiple contributors, right? Of course, it's usually multiple. It's not like only one of your program using all of the resources. But generally, there is this rule called Pareto, which is saying that, it's usually 80% of resources used by 20% of your code, things like that. So generally, there is some bottleneck, the thing that you should focus first to have the most impact. And bottleneck analysis is, again, something you can get from observability we could mention later on.
Does anyone disagree with that?
Everyone agrees. Everyone works on observability and monitoring, so who to disagree?
Yeah, exactly. Good point. Okay, so observability then. So this is literally like monitoring resource usage or the time it takes to do things. Like, is there a limit really? How do we know what to measure?
I guess it depends on what kind of program or service that you are writing, right? Let's take you have an online system and it's a request serving system like HTTP or gRPC. Maybe you are like putting this program as a service, and then we can talk about maybe service level objectives and what actually affects customer, like what are your error rates, what are your latencies. Then from that, we can come up with certain metrics and start measuring or instrumenting our code base. This is one example, but we also have different type of systems. Maybe they are not online request-based systems, but like they're batch processors or offline systems or some event processing system. Then you need to consider other stuff. So everything starts with knowing your basically purpose of your system.
Maybe I will play like a devil's advocate here, Kemal, and I agree with you, but I think that the general misconception these days is that as a developer, you are giving me some solutions for SRE, for DevOps, for operator that show me some kind of metrics of SLOs and service availability. But I am developer. I don't care if service is up or not. I care if my code is faster because I'm paid for making the software better, right? So how those tools kind of like relate to me?
By tools, you mean like observability signal collecting tools?
Like metric of HTTP request on my SLO dashboard. How can I use it for efficiency improvements?
This is your North Star metric, right? Like the most important one. Because like think about we are having a website and you are actually serving a website, and the most important thing for your user is like how fast it actually renders, because like the psychology shows us like there are some attention spans and they are getting fewer, like lesser and lesser every day. And so you need to be fast, right? Or even like before that, if you are serving that request like with a success, so you need to know that. Like that's why I always advise to start with these type of high level metrics. But then, like, let's take latency, right? HTTP request latency. You're serving this website, but then you can drill down, like, what does this mean for the system? Like, what contributes to this, like, latency? If you think of and then tracing observability signal, it's a span, right? In that span, you have different spans, like different methods or different components in your system that takes time. And now you need to get in there and understand like why it is taking that much time. Maybe you are doing a calculation that is not that efficient in your hotbed, or maybe you are allocating too much memory. You need to know about it. But it always starts with your high level goal and drilling down using different observability signals and maybe instrumentation.
Yeah, great. So exactly right. I was kind of challenging you, but like generally, yeah, I agree. You can use the same metric kind of pipeline. So the same client instrumentation in Golang, where you are either importing some library with this instrumentation, or you have instrumentation built in, maybe Prometheus, maybe something else, maybe OpenTelemetry. And you have that built in, and the same thing that your SREs are using, your operators, or like, people who are running your software, maybe you are running, that's ideal, but sometimes you are not. And then as a Go developer, you could use exactly the same metric, for example, HTTP latency, as your guidance, as your assessment value, if you are improving your code or not. So that's kind of like important part of observability / monitoring here that kind of can be composed into like something useful for efficiency.
So say that you've got this set up then, and you've got a good idea of some kind of metric on your code, and hopefully what it's doing in production. Because that's the other thing, like having you it might work great on your machine, but once it's running at scale, for whatever reason, just the way it interacts in ways you just wouldn't expect, maybe. So environment's very similar. I think it's probably good advice. So say you've got that. Do you like check that every time you do a PR? Is that something that you keep an eye on things to see if you've made a difference? Or do you just do it kind of periodically? You'll just have like once a quarter, you'll just have like, let's do a performance check. How do you approach it?
Like we haven't jumped into that, but right now I'm working on a continuous profiling tool, right? So we haven't even basically defined the profiling, but let's say we define, and profiling is kind of an observability signal. It's an action that you collect the resource usages of your processes that running on your machines, right? And what makes it fun is this continuous profiling part, right? So you are profiling all these processes, and then you release a software. Maybe you scale up, you scale down, but you always have the snapshots of memory usage or CPU usage in a time span, right? And then you can actually check between versions if you actually change something. So when you have a continuous signal like that, you can actually optimize or like do something about any of these actions, right? Same goes for like metrics. Like you have a latency metric and you can define some SLO-based alert on that, and that the alerting part actually makes the difference, right? So all of a sudden you release a version and your latency has spiked and it actually triggered an alert. Now that you know that, like, since you put that alert in there, you know that you are actually exceeding your allowed boundaries, your error budgets maybe. And then you can actually get in there and try to optimize, right? Try to do something about that. But it's the fun part of that, right? We mentioned the profiling side of that, and we mentioned the metric side of that, and we mentioned the alert, right? They come all together, actually. You get the alert, you check what's going on with the process, down to the like method and function, and then you decide to do something about it.
I think it's great. I think you are kind of explaining the production assessment level, right? So when you are actually, building your PR, merging, everything deploys, you release it to different, environments, and finally it gets to production, and that's your assessment. That's probably the ideal assessment in terms of kind of how reliable it is, right? Because that's actual production. That's what matters. Things are not very easy if you maybe distribute the software to different productions or maybe, to different customers. So probably it varies. That's why I think it's very useful to think about this problem the same way as we think about testing, about functional testing. We also have unit tests that always are running on PR. We have integration tests that sometimes are running on PR, depends how much you want to pay. And there are production tests or load tests maybe, and end-to-end tests. There are different kind of levels. And no one is saying you should always only implement unit tests and nothing else, or only implement end-to-end and nothing else. There is graduation process where things closer to the code cost less, but it is not always reliable. And then things farther away towards production is more reliable, but it's kind of sometimes too late because the feedback loop is very, very large. So this is exactly the same for assessment, right? You have micro benchmark, which is kind of a unit test. Then you have macro benchmarks, which is kind of integration end to end. And then we have production assessment. And the problem is these days, ideally we run on every PR micro benchmarks, but we don't, because it's still very expensive, it's still unreliable. So we hope maybe hardware will get cheaper. I mean, there are some kind of solutions that do that. Sometimes we do that, but generally it's not achievable yet. What we have in Prometheus, for example, we have macro benchmarks. So we spin up a test cluster with Prometheus server, which is kind of like written in Go, like some time series for metrics, right? And then we can kind of spin up this setup on the PR. So we say, hey, prom test kind of start. And then it starts, it gives you dashboards, it gives you results, and then you can shut it down because it costs money for the CNCF organization. So they hunt us afterwards. But generally, ideally the space is better and we run everything on the PR, but that's not the case always, right?
I guess for us, we also have that kind of faceted tools before we cut a release. Like at Grafana Labs, we usually cut a weekly release and then go through different stages, like more the internal tools and then into production. And we would really only alert on SLO. So we would kind of, if we think it's worth, we would compare our benchmarking in the PR, but there's not an automated way and there's not a good way of kind of raising a question mark about a PR once things would go out of hand. And I think I was wondering how that works with the prom bench. Do you get a kind of percentage assessment and then the reviewer needs to make a call, or is it getting kind of hard rejected in the kind of PR pipeline?
Yeah, it's very manual, right now, because again, it's kind of community project, so it's not tied to any one production kind of environment. So it will be hard, but it's kind of manual these days. But it's good enough, right? However, I think that if you look on the Vitesse project, I think it's kind of in Go as well. And they have amazing page around benchmarks. So they do nightly benchmarks, like all micro benchmarks in the code base. So, in Go, benchmarks are kind of built in, the micro benchmarks. So you can use Go test to run your benchmarks, and they are very, very nice and easy to write. And if you have them in the code base, you run a specific Go test command, it will just run everything. And they kind of try to have hardware, so kind of virtual machines which are stable, but also, by the way, running virtual machines also sometimes unreliable because there are noisy neighbors, the characteristic is different. There are so many complexities. But sometimes if you run it long enough, it can give some data. So on their website, they're having the results for every nightly builds, and pretty sweet, yeah.
We are going to ship in 3, 2, 1.
I'm Gerhard Lazu, host of Ship It, a show with weekly episodes about getting your best ideas into the world and seeing what happens. We talk about code, ops, infrastructure, and the people that make it happen, like charity majors from Honeycomb.
We act like great engineers make great teams, and it's exactly the opposite, in fact. It is great teams that make great engineers.
And Dave Farley, one of the founders of Continuous Delivery.
Start off assuming that we're wrong rather than assuming that we're right. Test our ideas, try and falsify our ideas. Those are better ways of doing work, and it doesn't really matter what work it is that you're doing. That stuff just works better.
We even experiment on our own open source podcasting platform so that you can see how we implement specific tools and services within changelog.com, what works and what fails.
It's like there's a brand new hammer and we grab hold of it and everyone gathers around, we put our hand out and we strike it right on our thumb. And then everybody knows that hammer really hurts when you strike it on your thumb. I'm glad those guys did it. I've learned something.
Instead, yeah.
I think that's a very interesting perspective, but I don't see that way.
Okay.
It's an amazing analogy, but I'm not sure that applies here.
Listen to an episode that seems interesting or helpful, and if you like it, subscribe today. We'd love to have you with us.
I think I'm going to disagree with Bartek, at least partially, about testing this stuff. So here comes my first unpopular opinion. So even though like testing and doing end-to-end tests like or synthetic benchmarks on your development machine or like on your CI, your development environment is not the same with your production environment. So I am a big fan on like collecting these metrics on production or like just profiling the actual workload in the production, because the CPU, the machines, the network stack that actually this software runs on is totally different than what you have in the CI or in your local machine. So if you can do this on a production environment, that data is also like the actually holy grail, right? On top of that, like one other thing is with the Prombench or with Prometheus project, right? We actually know what is the hot path. So that's why we have those like benchmarking tools, and we know what to optimize, and we know beforehand that like what shouldn't go out of range, right? So that we have that in CI. So it's really helpful. But most of the other projects, you don't have this information and you actually don't know what to optimize. So there's a lot of unknowns. So for those type of things, I actually doing this on production with certain metrics or like certain facilities to collect this data is more valuable to me.
Yeah, could you have like a budget so that you say like, we're going to add features, we're going to add extra work. So we know that's going to slow it down, but we want to set a budget for how much we could do that and something like that. Those kinds of techniques. Does that work?
I think I'm always a fan of having maybe 2 feature sprints and then one tech debt clean up, maybe bring those new inefficiencies or newly identified hot paths, maybe fix them, make them more efficient. Like I think that seems to work quite well, I guess. Like, and we also notice in the project, if we run too many of the feature sprints, then like I guess we're gonna pay in terms of getting a bit more red graph when we look at our SLO budgets.
Yeah, it's quite nice because you can kind of free yourself and focus on the features. And then you know that at some point you'll then go back and have that dedicated time to do the pay off the tech debt or just see what the impact is.
Yeah, you don't know how a particular feature is used. I'm now working on continuous profiling as well on Flare, but before on Loki we implemented deletions and we had an idea what kind of requests to expect, but like I guess within the first month we hit very interesting requests in terms of their size and just the number of them that we kind of didn't kind of optimize for, and that then required another sprint of making actually scale to that level.
Was it just that people wanted to use a new feature, so they're like, right, what can we delete?
Yeah,
let's do it. Because I'm like that when I get a new phone. I'm like, I'm using all these features because they're new, and I've it's an expensive phone. So
let's delete every second line of your logs.
Yeah, why not? Maybe halve your bill.
Yeah, I think it's always kind of depends on a case. But I wonder, let's say you have those weeks for the feature development, and then you deploy those features, and SLO is, or like some kind of like this measurement assessment is red. What do? Wait until the tech debt, or you revert the feature and work on optimizations? This is where this things kind of is tricky, right?
What do you do though, Christian?
Yeah, I guess like we look at our budget, and I guess as long as we are within the budget, I guess we can kind of push it down the line, I would say. But yeah, I think if we kind of exceeded our error budget, then this definitely becomes like not a P1, but like definitely like will kind of drain out all the feature work.
Yeah, makes sense. Yeah, definitely. And it's like kind of like data-driven approach where you kind of like express everything in number, like, hey, how much I can sacrifice. And however, the problem is usually like people don't set the goals, don't set the performance requirements or efficiency requirements. And for maybe service like yours, you have some latency, but what about the memory used or other costs like CPUs? Like it's so hard sometimes, and we don't always do it. Even in Red Hat, it's like you add the feature, but what's your requirement? What's your goal? Like, are you happy with spending thousands, or it should be $2,000 per month, or it should be 10,000, or it's kind of like ideally you have the goal because you can calculate those budgets then, both on latency and resources, which is costs, right? So I think that's the trouble that many engineers have. It's really hard to set the goals because it sets you for failure. There's kind of like psychology behind that. I think we should do it more. I think we should set more goals to know our budgets, essentially, right?
Yeah, I think it doesn't help that the billing cycle, for example, from cloud providers is not really matching up maybe with your kind of release cycles. Like they're often delayed or kind of over longer periods. And so like we definitely kind of got that with a bit of delay, and then was even more important because I guess it aggregated over the time frame.
Yeah, that's a cool problem to keep in mind. Yeah, I guess there are tools like OpenCost or kind of like even CNCF tools that kind of gathers, some observability about your projects and even Go applications, and then you kind of try to calculate the cost. So yeah, maybe that will help. But yeah, generally hard problem to solve.
Yeah, so that's really interesting. Kemal, you mentioned earlier, like, really the best way to get this data is to do it in production. Is there a cost to that? Because you're doing extra work to get that observability data out. Does that itself not slow things down?
Of course, there's a cost attached to that. There is no free lunch, right? So that's why when it comes to observability, you actually, or at least I tend to start with metrics, right? That's the low cost observability signal that you can collect from your systems, because it's just an aggregation. And if you are actually monitoring your system using Prometheus, it's just in certain scraping intervals, you just like get your aggregated metrics and just store them, and you build your alerts or dashboards on top of that, right? This, like, as far as I've seen, in most of the cases, our metrics are super useful and does the job, right? But the most of the cases, then there's this like in-depth situation, maybe you need more information about your system. Maybe that's where the logs comes in, or any eventing system that you collect from your system comes in, and you check what's going on with the events, right? If you have tracing data, this is really nice, because then right now you can actually propagate your context between other services or other context boundaries, and you can have a broader picture of the system. This is another observability signal. But again, there's another cost attached to that. First of all, it's really expensive to store the tracing data. And the other cost is you actually need to instrument your code, right? And it's like tracing instrumentation tend to be a little harder when you compare to the metrics, because you need to go in there and you actually semantically determine which function boundary that you are crossing, and you need to just propagate that context, or you need to do this, all the systems that you have in your architecture, right? But like metrics, in that sense, it's easier. And we know logging, everyone likes to omit the logs, even though I find them super noisy, and it's like really hard to take actions against them when you have hundreds of instances of the same process, right?
Were you the one deleting them then all that time?
I tend to just not store them, even though I really like writing log lines, because while developing, it's a single process. I know what's going on, and it helps me a lot. And then on top of that, you have profiling, right? And it's really easy to profile your applications using Go, but profiling is specific to resource usages, right? To actually debug and introspect and understand what's going on, maybe troubleshoot a problem, you actually need to combine all of them, right? Because every signal has its own use case.
Yeah, something that you cover in your book, Bartek, and by the way, congrats on the book.
Thanks.
I don't get a kickback from it, so I can just say it is available now. So if you want to learn about writing efficient Go, get it. In your book, I know that you mention this trade-off between features and performance. And we've kind of talked about this when you sort of build up tech debt as you go along adding features. Does this argument happen a lot where you're making the case to not have a feature because of the cost it's going to have? And then what about like product people or sales people or whatever else that are working there that obviously incentivized really for the opposite thing maybe? How does it go down?
Yeah, totally. It's kind of everyday question almost, right? Like if we should invest in some amazing feature, and especially deletion is an interesting one, right? Because we usually, at least in our ecosystem of like Prometheus and Thanos project, as well as Mimir and Cortex and Flare even, and all those kind of like distributed systems, or not distributed, like time series database, or sort of kind of like storages for different observability data. We kind of store it in immutable storage. So once you kind of like try to delete something, it can cause problems. And it can cause cost, right? So that's kind of like the question, when we should add, how much of the flexibility in deletion we should add, and sort of those stories. And it really, really depends. And kind of like what really helps is to have this budget of like how much cost you want to kind of add to the system. And, even like developing a feature is a cost, like spending engineering time and testing and maintaining it. I really kind of try to recommend using the same pattern for like discussing, how much you want to invest in kind of efficiency of something, if we should kind of make it faster or not, or we should maybe disable some feature because it was kind of slowing the system. This is exactly the same discussion as you would have should you add some feature, right? Because again, like it just about thinking about efficiency. It's still kind of some cost. It will be some cost of like, maintaining and so on. So everything ideally in ideal world, the cost of it. So if deletion is kind of how much deletion request will cost, kind of roughly CPU time and if you have the capacity in your cluster. So this should be kind of like the core discussion to have. And if users are willing to pay for that, sure. But if, for example, you want to kind of minimize the cost, maybe you should disable this feature. It really depends on what user you are in and what project this is in. But generally, speaking about like data numbers is kind of helpful, and treating everything as the whole package, right? Not just features as readability and maybe complexity of the code or API or configuration, but also add efficiency on top, like roughly the cost essentially. It just helps to make the decision, right?
Yeah, and I guess it's like what the business leaders in the end care about. I guess they want to kind of maintain their margin, and the closer, I guess, to those numbers you can get from your system, from your production system, like I think the easier you will be able to kind of flag issues there. I think like if like, for example, that deletion feature is for free and you actually ramp up a lot of costs, I guess that will kind of target your whole margin as a product. And like, I guess you want to know about that before it really turns it down into a negative.
The best performance improvement I remember I ever did in my whole career, I made something about 1,000 times faster by removing a time.sleep that I'd left in there by mistake. They were thrilled. They were like, this is really fast now. I look like a hero. Instead, I was, of course, an idiot in the beginning. So do you recommend that? Put some time sleeps in early and then you can take them out over time? Or is that?
Maybe it's a genius move, right? You just put them in and then remove. Ta-da.
Ta-da.
It's an improvement.
Yeah.
I mean, this is not a joke. Like literally, I was hearing some stories from AWS or some other service, and I would need to dig it up, like what the source of it. But generally, they were having a service and they added sleep to the service to not give too fast expectations for people, right? Because they knew they want to implement additional complexity, additional features. Imagine they were, doing, for example, like this database, and they want to add deletion later on, but they didn't yet. So that's why it's so fast. But they know they will add it, so they added sleep. So once they added this deletion or some other feature, it gets so slow, they have to remove the sleep, and now everyone is happy. So literally those things are recommended, honestly, because if you are kind of like, this is this budget and goal thing. If you are agreeing with your customer that your service is, responding under 1 second, having it respond in, 100 milliseconds, if they pay for 1 second, sometimes it's not smart because people kind of depend on it forever, even though you kind of agreed on 1 second. So those kind of like slowdowns on purpose, they kind of make sense sometimes, right?
Yeah, but isn't that the kind of thing that gets leaked at some point and then there's a big outrage? Like, and I don't know if this story is true, but I heard a story of like Uber checking your battery on your phone and charging you more if your battery is really low. I don't know if that's true or not, but it's a scandal. Imagine if they said, this service is deliberately slow.
I mean, let's not go there, but the AWS story, I think it's fair. Like you paid for 1 second and that's fair. Like they want to make this project sustainable. But what you mentioned is kind of like maybe less legal or less clear. But there are things where, how it's called, like when companies want you to buy a new phone and they will put time sleep into your keyboard. So it's kind of slow on purpose. Like things will happen like that. So that's unfortunate. No, we are to improve efficiency in this podcast, not add problems of efficiency. Yeah.
But I guess it's legit if it doesn't exceed your error budget or if it's in your like service level agreement. So you can like read the battery levels or put a sleep in there and slow things down.
Yeah, the problem is like now you are buying a phone and you have a list of efficiency goals. Like your keyboard will be always, swiping going from bottom in half a second. And, it's the same with SLOs, like how much granular those kind of numbers can be. It won't be granular to your local library method in Golang, right? It will be kind of like very high level. So that's a problem of the requirements, really. And that's why every team should have some rough numbers, because you are developing your library and, the SLO is impacted. Is it your fault? Is it somebody else's fault? Like how fast I should be. If 1 second is the goal, then your program is doing many things. Like my library and my team is developing, like, should it be, how much of this second, right? So those are not easy question. But again, with things like metrics, with things like profiling, you could, kind of find this number easier.
Yeah, another valid use case for sleeping in code I've seen is literally to add a random sleep to sort of jitter requests around as well. And I think that kind of makes sense because then it's about you're really helping. And as long as, like you say, it's within the budget, maybe it's okay. So how does Go compare to other languages and other technologies when it comes to observability, profiling, and being able to actually introspect things that's going on inside the programs? Is it good? Are there good things and bad things? Anything you wish you'd change? Something you love? Christian, what do you reckon?
So I generally would say it comes with batteries included. So I think compared to other languages, when you install like the Go version, that is the most recent one, like everything is already on your machine. Like you have basically like the runtime already kind of takes care, for example, of the profiling, and you basically just need to tell it to do it for your particular either mini benchmark. I think in other languages, you often rely on some external tooling or kind of intercepting somewhere. And yeah, I guess that makes it kind of available for any program built on top of Go or built with Go. And yeah, like just sets a certain standard, I would say.
I guess I can jump in here. Like we mentioned the signals, right? For example, one of those signals are metrics. And Bartek and we maintain a Prometheus client Golang library, which is one of the first Prometheus libraries, right? Surprise, because Prometheus is written in Golang.
Good choice.
So from the beginning, the support for metrics for Go was like a first-class citizen, right? On top of that, Go runtime itself also provides facilities to actually make your programs are more introspectable or observable, right? One of them is profilers. And Go from the beginning actually have pprof, which is a project from Go, it's Google itself, and it's embedded in the runtime itself, and you can actually expose this profiling data pretty easily. You can actually write, and when you run your tests with just addition of certain flags, you can actually dump CPU profiles, memory profiles, or you can just like add a package and add an endpoint, and then you can expose a profiling pprof endpoint, and then pprof can scrape and collect profiling for that. This was there from the beginning. So like profiling, Go is kind of built in profiling in mind. We also mentioned metrics. And one other thing that we can mention, there is an ongoing PR and a discussion around structural logging, for example. Go has a standard logging library, but now they're trying to improve that. And there are certain like controversial opinions around that, but still, like, I think as a community, Go always thinks about observability and how to make the programs more observable, more introspectable.
So it sounds pretty good then. Are there any downsides? Anything you wish it did differently?
Kind of. I will jump again. I'm super passionate about like profiling, right? Go itself has a profiler built in, and you can actually expose certain types of profiles out of the box, right? And they're super useful. But the approach that you have with the Go, for example, it's an interrupt-based profiler, right? And you are using certain operating system facilities, and I'm talking specifically about Linux in here. You need to set iTimer syscall, and then you register a a call, and then operating system itself is sending you some interrupts, and in those interrupts you actually dump the stack of your process itself. It's actually, you are changing things a little bit when you want to observe the system itself. So I think this is a downside. And right now, with the improvement of our technology in different parts of the stack, you can actually collect these profiles without paying this cost attached to this.
But I guess you could turn off those profiles, those native profiles, if you are a user of eBPF or some other solution that gives you those information from other sources. I guess it's not Are you able to turn it off? Isn't that the solution?
You can definitely turn it off, but I already told you that I'm a big fan of doing things in production, right? I want to profile my applications on production, so I'm always thinking about, in that case, right? How can I actually profile this process in production without paying any cost?
Yeah, I guess kind of like you are profiling on production. You need profiling for production use, so that's your production. So that's the cost you are paying, and then you account for that. But yeah, I know what you mean. The more it costs, your observability stack can sometimes cost more than your compute power on normal applications. So this is you need to be very careful what signals you are deriving, observability signals you are kind of getting out of your application, because you can get crazy here. So yeah, things like metrics and profiles are my favorite ones for efficiency. You can make them kind of cheap enough for it to be profitable still, but I know your point, and all those kind of things that are happening in the profilers, either moving it to kernel or kind of in a Go runtime, making them kind of cheaper to run and more accurate in the same time, are amazing things. And in every Go release, we have some improvements of that, so it's pretty sweet.
Yeah, maybe we should chat a little bit more about eBPF. This is something that I see a lot, and I see people getting quite excited about it. Liz Rice, I think, has an eBPF book, and it's called Runtime Security, I think, wasn't it?
Something like that, yeah. And, it was on security, and kind of that was kind of the main maybe hype for eBPF, but definitely it's used much more.
There is another book, I think, What is eBPF, if I'm not mistaken.
Yeah, so that's also the first Google result I found. But
well, there's definitely a talk. We'll find out and put this in the show notes. But what is eBPF? What actually is it?
So I guess I kind of alluded that this is the different, the Neve solution in the different part of the stack, right? eBPF is actually, Bartek is actually showing us the book, so we will add the link, I guess.
Yeah.
So eBPF is a new technology in the kernel space. It actually invented as filtering certain packages, but the acronym became a technology itself. Basically, it's a virtual machine and a verifier that attach to your kernel, and you write your C programs, or you can also write the programs in Rust, and you can target this virtual machine, and then kernel can load these programs in your runtime when the program is run. So what it helps, it actually really opens up a lot of possibilities for observability tooling, security tooling, or network tooling. Since our concern is observability tooling, with eBPF, there are subsystems in Linux, right? One of them is perf, which is for collecting certain hardware measurements from your hardware, from your host machine, right? Using perf subsystem, you can subscribe to the perf events, and using those perf events, you can actually capture the stack traces of your running processes. That is actually then you don't need to actually register something, but you just need to subscribe to this perf event, and you can aggregate, and this happens outside the process, right? This happens in the kernel space. So it doesn't actually change what's going on in your program itself. We cannot say that there is no cost. Of course, there is a cost. Of course, it's changing stuff because you are running some program in your CPU, but it compared to what you get from interrupt-based profilers, this is so minimal, even negligible.
Are you excited about eBPF?
I am totally excited. I'm going crazy about it. I'm also working as a Prometheus maintainer and mostly working as for client Golang, right? It's an instrumentation library. And recently I gave a talk in Prometheus days, and I was focusing on like how we can do stuff using eBPF without instrumenting the code, right? And mixing and meshing those things. And on top of that, I'm helping to build an open source continuous profiling project, especially for Go. It's called Parka, and like we are using eBPF to actually profile the processes. So I'm all sold out. I don't know.
Yeah, you're all in.
I'm all in.
I think is going to be a popular opinion, but fear not. It wouldn't be go time if we didn't explore your unpopular opinions.
I actually think you should probably leave.
I promised last time that I would kick us off because I forgot mine, and I've brought two. I've brought a serious one and a very serious one. And my very serious one is, I think from now on, the past tense of screenshot should be screenshot. So we should say like, oh, did you send that thing to Bobby Bucksmith? Yeah, I screenshot it to him. That kind of thing. If you've got no objections, we can probably sign that into law now. And my other one was the optional second return arguments that you sometimes have in Go, like when you're checking a map or doing typo sessions. I don't think they should be optional. I think you should either have to explicitly use an underscore to say, I'm ignoring this, or you should use it. Because I just don't think you should ever not use it, basically. I don't know if they'll be popular or unpopular, but we will find out. Don't forget, we test these on Twitter at GoTimeFM, so you can vote on a poll and decide whether this is indeed popular or not. Anybody else got popular and unpopular opinions?
Yeah, I can do that. So my unpopular opinion is that if you see in some software, if I see in some software, three extremely generic abstractions, and they usually are together, things like input, processor, and output, source, function, exporters, collector, processors, publishers. In most cases, those mean troubles. That's my opinion, really? Right? If I see this, I'm running in a different direction or try to find a replacement software. And I might be kind of like exaggerating, but one kind of example is like generic data pipeline or pub subsystems that supports every data format and maximum flexibility. And you can configure thousands of intermediate steps as the processor between input and output. Or maybe, sometimes I saw this like Go interface called processor with one method, do, and bytes argument. And those things are crazy, but I saw them. And the reason why it's bad is because the best abstraction is generally opinionated and small, and while the complexity of implementation can be higher because it's hidden under this abstraction, right? And there is a saying even, keep interface shallow, implementation deep. And those things with over generic abstraction happens, but they kind of cause so many problems. It end up you are programming in YAML at the end because there are so many kind of configuration for this input and processor and outputs. It poses limitations to implementations. It's simply inefficient. At the same time, the standard library kind of functions, that's kind of another popular opinion, I guess, but standard library sometimes are inefficient because they're very generic. It has to check different edge cases that you might not have. For example, parsing integer from string. If you don't have negative numbers, your function can be much faster if it's, of course, in the critical path. So things like that. Anyway, I was just seeing so many failures, so many projects abandoned even because they were following this like very over generic abstractions. And I want you to be cautious here. That's my opinion.
Oh, very nice. By the way, some of my best friends are YAML programmers, so let's not,
I mean, if you like it, sure.
Is it not just a failing of the naming? It's just that we struggle to name it, or is it literally like you mean about the input and output types as well? Like you want those to be very specific, ideally.
Yeah, it depends on the case, but generally you want to have like, naming, but also like underlying kind of, configuration options to be opinionated, to be limited, there has to be kind of like defined abstraction. Otherwise, it's, over open. So maybe, it kind of like it leads to abuse of the system as well. So if you want to have any arbitrary input that works with any processor, you end up with like reading PDF, filtering using, processor made for robots, and then outputting as a Helm chart. I don't know, like something crazy like that. And people will do it and then claim success. And it's just kind of like, it's like a waterfall of different problems if you are naming it kind of over generic, but also, having the interface very generic.
Yeah, it makes sense. I understand how it happens because you want to be so flexible and really smart, and you want to take on the pain so that it's easy for people to use. But I kind of agree. Like, if you can be more specific, then do. That's a pretty good one. We'll test it and see, Bartek. And if it's not unpopular, you are contractually obliged to return to GoTime and do another episode. I don't make the rules, but...
Sure.
Okay, do we have any other unpopular opinions?
Yeah, so I have an unpopular one. So basically on the Go execution tracer. So while it is very colorful and like I think you can learn a lot how maybe your program is running, like I think I've never found the problem, and I always started tracing when I was just desperate. And so my unpopular opinion is instead of starting it, go outside and do a walk in the park, and then maybe you see the missing error check or whatever it is.
Hey, that's interesting. Is that unpopular, Kemal?
Not in my book, I guess.
Okay, well, we'll test it, Christian. We'll see. Kemal, did you bring an unpopular opinion today?
I brought like a bunch of them. I don't know where to start, but I guess maybe I can just keep it simple and focus on the things that we talk today.
Keep Bartek happy.
Yeah, this one for Bartek. So I think Go should give certain APIs to control memory for certain use cases, right? Go runtime does a lot of assumptions for us and for the memory safety, and it gives us guarantees, and it's really nice with the garbage collection. But sometimes you really want to reduce the allocations. There are certain ways to do that, but it would be really nice to have some granular control on certain memory parts so that you can optimize your program for your hot path. Because as far as we see with the Go programs, it's mostly about allocations and the GC pressure. I know there are some improvements recently, like actually there are some knobs that you can turn and adjust your garbage collection. On top of that, there's this PR proposal about the arena support, but still, it would be nice to have more control. I think Bartek gonna like this because I know for a fact that he maintains a couple of packages around these to actually make this happen.
I feel like our opinions were not super unpopular, because I think I agreed with all of it. And I think there should be some legal agreement we are signing with you, Matt, that those words cannot be used against us or something like that.
Right.
But yeah, I would agree with Kemal. Arena is especially good, but I would even bring Rust ownership model to portion of your Go code. So you could kind of strictly control the scope of living kind of life cycle of your variables, of your data. And maybe only for 5% of your code, because this is the critical path that matters, and then use garbage collection for something else. I kept kind of looking, people look as crazy if I say that, but I think, I would even go further as that.
Yeah, so it kind of makes sense then. Most people won't have to know about it or even think about it. But when you are working, when you're doing efficiency work, when you really do want to control it and optimize it, that sort of makes sense. A bit like how you can have assembly in your Go code, I guess. That's a bit unusual to have assembly code in there, and people do it sometimes for very good reasons, but it's the trade-off between this is now very difficult to maintain, especially for Go programmers who typically don't write much assembly. And same then, you'd be able to, for those that need it, would be able to use it.
Yeah, I think we're going in this direction though, so it's good. Arena already is claiming some kind of part of your memory where, it's outside of garbage collection. So it's a precedence. Once that is done, we can go further, deeper into bad things, but also nice for efficiency sometimes, yeah.
Well, these all do sound quite popular. Does anyone want to have a go at a properly unpopular one?
No, before the legal contract, no.
I can go.
Come on. Let's dig deep. Let's find an unpopular one. Yeah.
Okay. I think the Go team should be an independent third party instead of something that only Google people actually controls. There are a lot of other kind of stakeholders actually depends on Go. And for example, one of the big ones is CNCF, Cloud Native Foundation. We work on the open source project that actually donated to that foundation. So it would be nice to have some representation in the Go team to adjust things, right?
Interesting. I know that has been a subject before, and I think it is quite a controversial one. But let's have that chat on Twitter. Or certainly we'll put that clip of you and then vote, and that's it. That's really how we do our observability and our data collecting. Excellent. Well, thank you so much. This was great, and we should do this more. We touched on profiling. We really didn't go deep on profiling, and I think that could be also great for a future episode. But thank you so much, Bartek, Christian, Kemal. Absolute pleasure. And thanks for listening. Thanks to our live listeners. Remember, this goes out live and you can see us on YouTube. And also, this is edited nicely as well for your podcast. So if you're listening to it on a podcast, then good for you. But there's some gold that was chopped from it. I suspect one of my unpopular opinions will have been cut out. So if I said I've got 2 unpopular opinions and then I only said 1, you'll know that one was cut out. But we'll see. Thanks very much. See you next time on Go Time.
It just so happens that this is one of those Changelog++ extended episodes. Matt and the guys stuck around for 12 minutes or so after the show ended to review how it went, discuss a few things they didn't get a chance to, and answer some questions from the chat. It gets a little spicy too. I had to bleep Matt at one point. If you aren't a ++ member yet, this is a great time to check out our membership program. Directly support our work, get closer to the metal with bonuses like this, and save yourself some time by making the ads disappear. Head to changelog.com/++ to learn more. Thanks once again to Fastly and Fly for partnering with us to bring you Go Time each week. To our mysterious friend for hooking us up with these dope beats. And to you for listening. We appreciate you. Finally, I'd like to thank all of our amazing Go Time panelists for making this show so stinking good in 2022. Shoutouts to Matt Ryer, Johnny Borsico, Natalie Pisanovich, John Calhoun, Chris Brando, Angelica Hill, and Ian Lofshire. Go Time is good because y'all are great at what you do. Thank you. Next up on the pod, it's a New Year's party, but it won't drop till 2023. I hope you have a great end of the year, and we'll talk to you again real soon.